Okay, so now we're going to do chapter 4, number 2. So refer to the clustering problem involved in the file FBS described in problem 1. Apply hierarchical clustering of 10 clusters using the football stadium's capacity, the latitude, longitude, endowment, and enrollment as variables. Be sure to normalize the input data in step 2 of the XL minor hierarchical clustering procedure. Then use Ward's method as the clustering method. And then we're supposed to do do all this stuff. Now this is all going to be after we get everything out. So let's go ahead now and go and do the actual analysis. So I'm going to close this just so I can import it into the what we need to go to. All right. So hopefully everybody is seeing this. Says we are. All right, so we need to go over here to Solver Home. And again, I'm using the Analytics Solver online. I'm going to open, and I'm going to open the FBS. And all right, so that's open now, so we can close that. And we can see here our data. Now we need to go to XL Minor Platform, because that's where we're going to do the clustering. We're going to do clustering again, but this time instead of k-means, we're going to do hierarchical. So we click that, and let's see what it tells us when we get there. All right, so we have to make sure we have the right data set, and so that's the data. And we were supposed to do stadium capacity, latitude, longitude, endowment, and enrollment. Okay, and then so that's raw data, so now we can go next. Now we need to normalize the input data, again, like it said at the beginning in the problem, and we needed to use Ward's method. Okay, so next. And then we want the dendrogram, and we also want the cluster membership, and they wanted 10 clusters according to the directions. So finish. Now it's going through the process. And when it gets done, it should load it over here in our Excel kind of page-like thing here. All right, so the mining operation has been completed. Now it should eventually load it, which it has done now. Now, a couple key items here. So we go back to our data. Then we have this analysis, and it gives us all this good information here. Gives us our clusters, which is another thing we need to do. But then it gives us the dendrogram. Now, the key here is when we export this into Excel, our dendrogram disappears because it says there's an error. Maybe it's just my version, but it gets rid of it. And so what I need to do is I need to actually copy it. So while this is going, I'm going to capture it. That way I can paste it. I can paste it hopefully into my Excel file. So copy. All right, so now it should be in my clipboard. And so now what I can do, I can go back to Solver Home, and I can click on the FBS, which we have, and we're going to download it now. And now what we're going to do is we're going to have to open our Excel file. And we'll see if it'll let me ever share the screen. All right, so did it open? It's still opening. Oh, there's an error with it. Yes, we want to trust the workbook. And we'll enable, and now hopefully you will be able to see it. So this is our thing. Now if we go to dendrogram, we can see that we don't have it here. And so what I'll do is hopefully it stayed in my thing here and it's copied into there now. Now what I will do is I'll kind of shrink it down a little bit. That way we can actually see it all hopefully on just one screen here, at least most of it. So that's our dendrogram. All right, so now back to the question. Yes, the question disappeared. Great. Let's see if I can. All right, the question disappeared in the original too, it looks like. Let's try it again. There it is. And we'll copy that, put it into our original here. Whoa, let's spread out. All right, so what we're supposed to do now is use the pivot table on the data in the HC clusters, so that's going to be this one, and compute the cluster centers for the clusters in the hierarchical clustering. So let's go to this. So this is what it says to do. So we're going to do this whole table. That's the table they're talking about. And we're going to insert pivot table. And since I'd already highlighted it, luckily it put that there, we're going to go ahead and put it on a new worksheet. So it's just totally separate, so we don't have to worry about anything. And so let's just select everything because we're going to maybe look at different things. I'm not sure what the best way to look at this is, so let's do them all. We're going to need this here, so that'll give us the row labels, so the cluster row labels. And then we want, instead of sums and everything in this column, we're actually going to use something different. Here, let's use the count. So that way we know how many of cluster 1 there are and how many of cluster 2 and so on. Now, instead of sum of the stadium capacities, that's not going to be very helpful, but if we have an average, that will be very helpful. And what I'm going to do, instead of having just a general number, I'm going to have 0 decimal places. That way it's just kind of easier, and it gives me kind of a whole number to look at, and it doesn't matter because 0.2 people is not really helpful. I'm going to do similar things on the rest of these. I'm going to do the average, and I'm going to convert the number to 0 decimal places. And so this takes a while because you have to go through each one of these. And so bear with me. Hopefully everything then is going to work. Average. And so now we just have the last one here. And you could leave it at 2 decimal places, but sometimes on some of these, you'll get like 6 or 8 decimal places here and 6 or 8 here, whatever. So it's just easier to go ahead and put the 0 decimal places. All right, so that gives us everything we need here, I believe. So we can get rid of our field here, so that way we can have just strictly the table. Now the question was, compute the cluster centers for the clusters in hierarchical clustering. So that's what we've just done. We've done all the clustering. So we can see these are the different clusters. This is the count of each cluster, the average stadium capacity for each cluster, the average longitude, latitude, enrollment in thousands of dollars, and average enrollment total. Oh, this is endowment, not enrollment. All right, so that's what we've done there. Now B, identify the cluster with the largest average football stadium capacity. Using all the variables, how would you characterize this cluster? Okay, largest stadium capacity, if we look through those, it looks like that would be the largest stadium capacity. So it looks to be that cluster 3, which has a count of 15 items in the cluster, has the average stadium capacity of 87,616. The average longitude is -93. The average latitude is 32. Average endowment is, a little over $1 billion, $1.1 billion. And the average enrollment is $38,993, or 93 people, sorry. All right, so that's kind of what basically our letter B is asking for. Using all the variables, how do you characterize it? Well, we just kind of went through each of the columns and said what happened with that column. Now C, examine the smallest cluster. What makes this cluster unique? All right, smallest cluster, that's 1. Well, what makes it unique? Well, it's in cluster 10. 50,000. Well, if the average is 52, that doesn't look to be something too different. Here's the -122 longitude. It's it's a little bit different there. It's right on latitude. Here's something different. The average here is $1 billion, but they have $16 billion. So that would be a key one to key in on, because this one, it's up and down. It's right in there. So the one that looks the most different of all of these that would actually have a reason to be different would be that average endowment of the $16 billion. Because remember, add in another 3 zeros, and so that would put it at 16 billion. And so I think that's what they're wanting us to see here as far as what is so unique about it, and it's basically the average endowment. All right, now by examining the sequence of clustering stages in the HC output, which is this little button here, and the accompanying dendrogram, which we copied over luckily. On the HC dendrogram worksheet, recommend the number of clusters that seem to be the most natural fit based on the distance. By comparing the total distance at the stage with 8 clusters to the total distance at the stage with 7 clusters, compute the increase in distance if 7 clusters are used instead of the 8. All right, so we're supposed to go to HC output, and then this is what we're going to look at here. I think what I'm going to do, I'm going to copy that, create a new table, paste it in, and now what I'm going to do is I'm going to say, okay, this is going to be the clusters, and then I'm going to maybe say this one distance increased. And because this is going to help me kind of average and look at things here. So clusters, remember we started with 127, and then we're going to basically subtract off, and I'm just going to say which stage it is, because every stage we're going to subtract off one. I forgot to put equals, I guess. 127 minus stage 1. And so that gives me 126 clusters. And now what I'm going to do is copy that down to the end, and that way it'll basically give me a reverse count all the way down to 1, okay? Then this one, distance increased. Well, we can't increase distance off the first one, so really that first one's just going to be that first one. But now what we can do is we can say, well, the distance increased is going to be our value here minus the value here, because we're going to increase that distance. So it's going to be the D3 minus the D2. And we really could have had a D2 minus this one, but we have a name here, so we can't do that because that minus that's going to give us an error, and that won't work. And so then the next one here, going from here to here, that increases the distance, and it's going to be just the next one down the line. So I'm just going to copy that down again. And so that's going to give me all the distances that increased. Now let's look at that and see what it looks like actually as a graph. So insert graph. Let's do the line graph. We could put dots on it too, but a line I think will work for what we need to do. Let's see if it'll go up to the top. All right, so that gives us the line graph basically for what we have here. And so we can see, you know, not much change, not much change. And really kind of right here is that's the first major change is right here. And then we kind of go down a little bit further, and that's kind of, this is a kind of a big change after that, and this is another big change, and this is another big change. So this first one looks to be around 16. So that means we need to go to cluster with 16. This is going to help us find recommended number of clusters. It seems to be the most natural fit based on the distance, and that's what we're doing now. Is we found that distance, and where did we put it? Where did it go? It must be here. All right, and we found that distance. And so we're looking at the change in distance. And so if we kind of go down here, we really see 0.01, 0.00, 0.0, 0.0. So they're really all pretty small. Now, once we get down here, we get to see some that start getting a little bit bigger, 0.3, 0.3. But that big one we saw was going to be going from the 17 to 16, because that's 0.9. So that's kind of almost 1. So we'll say that's going to be our first one. So maybe this is going to be one of the cluster range, upper limit that we want to use. And then when we go down here, let's find one that's kind of really big. And well, here's 1.8. That's kind of big, but you know, let's just stop at this one, because then after that we can start seeing it does a lot of changing here. It gets pretty extreme. So let's say between 8 and 7, that's a major distance of 2.7, and they kind of hinted about something over here with clusters 8 to cluster 7. So let's go with that and say this is kind of the cluster lower limit, kind of what we would use. Okay, and so that's going to be what we have. So we can see that that distance of increase going from 17 of them to 16 was an increase of 0.9, and going from 8 down to 7 clusters, we went up to 2.73. So that's the distance. And so when it asks us, but comparing the total distance at the stage with 8 clusters to the distance with 7 clusters, compute the increase in distance if 7 is used. Well, that's going to be our 2.73. Okay. Now, if we went instead maybe from 10 to 9, there we're only going to go by 0.1. Okay, so here we're going from 8.64 to 8.74, so we've increased by that 0.10006. Whereas here we went from 9.3 to 12.0. Okay, and that's kind of going to be what we're going to do with their dendrogram. Now we're just going to kind of look how that looks here. So what we're going to have to do is insert a shape. Let's do a line. Hopefully we can make it sort of horizontal. Let's see, something like that maybe. Might not be perfect. But if we go back to our 7 and 8, 8 was at 9.319. So let's copy and paste. We have 2 of these. So 7.3, that's going to be probably about right there. And then our other one was at 12.05. So that would be about right there. And that doesn't, something doesn't seem right. 9.3. 9.3 would be the other one. I had 6.3. Right here. Okay, so it's lined up right on that. Right there. All right, so that's going from 1 to the next one. And so that's going to be the jump going from 8 clusters to 7 clusters. And we could also, go from, this would be the 9 to 8. So that's a much smaller jump. That's why we kind of picked the other one. And our first major jump, that would have been, let's see, about that one right there. That would have been about our first major jump. Okay, so you count across the number of times it hits the each line going vertically. That's going to be your number of jumps. So that's kind of what we've done here. We've recommended the clusters seem to be the most natural fit. Well, that would be the 8 and the 17. But comparing the total distance with 8 clusters to the total distance with 7, that was the 2.7. And so that's kind of what you're going to do there. And hopefully this helps you figure out how you're going to do pivot table, how you're going to look at the cluster with the largest, the smallest, what does it include, and then kind of looking at your output and seeing what you have. And you could always just stay with your output in the analytics solver when you're doing homework problems. But if you're actually going to submit something for the assignment, you need to actually download it to Excel, and this is the best way. And again, remember, you need to copy that dendrogram from the analytics solver into this if you're using the online version instead of just the actual PC web inside an Excel based version. So I think that's all I have here. So hopefully that will help.